In this example, we're going to solve an absolute value equation. The absolute value of 2x minus 3 is equal to 2. Now, the way we solve an absolute value equation is to split up the equation in two cases. And the two cases are where we just drop the absolute value bars and we get 2x minus 3 equal positive 2. And the other case where we get 2x minus 3 equal negative 2, or the opposite of the right side. We solve these two equations, and they're pretty easy ones to solve. 2x minus 3 equals 2. We add 3 to both sides. We get 2x equal 5. Divide both sides by 2, and you get x equal 5 halves. The other equation, 2x minus 3 equal negative 2, we add 3 to both sides, resulting in 2x equal 1. Divide both sides by 2, and we get x equal 1 half. And we have to check both answers in the original absolute value equation. When we plug 5 halves in, we take 2 times 5 halves, which is 5, minus 3, that equals 2. And when we take the absolute value of 2, we get 2. So that checks out. The other solution, x equal a half, we take 2 times a half is 1. Minus 3 is negative 2. When we take the absolute value of negative 2, it turns into positive 2. So that checks out as well. So both answers check out. Our solution is x equal 5 halves and x equal 1 half. Now we're going to use the same procedure to solve a little more complicated absolute value equation. We have the equation absolute value of x squared minus 1 equals x. We apply the same principle. We drop the absolute value bars and let x squared minus 1 equal x, the positive case. We drop the absolute value bars and let x squared minus 1 equal the negative of x, and that's our negative case. And now we solve these two equations. In both equations, we add 1 to both sides to get a quadratic x squared equal x plus 1 and x squared equal 1 minus x. We have these quadratic equations. We have to figure out how are we going to solve them. Well, the easiest way to solve equations like this is just to write them both in the standard form with all terms on one side and use the quadratic formula. We do that. We get all the terms on one side for the first case. X squared minus x minus 1 equals 0. And in the second case, we get x squared plus x minus 1 equals 0. We plug the coefficients a, b, and c into the quadratic formula for each case. In the first case, after we simplify our answer, we get x equal plus or minus the square root of 5 over 2. And in the second case, we get x equal negative 1 plus or minus the square root of 5 over 2. Now we have to check these answers, all 4 of them. And it would be pretty tough to check these answers in radical form. The easy way to do this is to get the approximate decimal form. 1 plus the square root of 5 over 2 is 1.62 rounded. 1 minus the square root of 5 divided by 2 is negative 0.62 rounded. Now I crossed off the negative answer right away because we cannot get a negative to work in our original equation. On the left side, we're taking absolute value, which makes it a positive amount. There's no way a positive amount can equal a negative amount. In the second case, negative 1 minus the square root of 5 divided by 2 is negative 1.62. That one can't work, so I cross it off right away. It's a negative. And negative 1 plus the square root of 5 divided by 2 is 0.62. Now we still have to check those positive amounts. 1.62 squared is about 2.62. We subtract 1 from that, and we get about 1.62 on the left. And when we take the absolute value of that, we get 1.62 or close to it. So the 1.62 solution works out. The positive 0.62 solution, we square that and we get about 0.38. Subtract 1 from that and we get almost negative 0.62 on the left, but we're taking the absolute value of that, and that turns it into positive 0.62, which matches the right side of 0.62. So both of those positive answers work, and they correspond to 1 plus the square root of 5 over 2, and also negative 1 plus the square root of 5 over 2.